Hello everyone, welcome to today's session. Let us start by giving you all a quick brief on what OctaNet is. So, Tech OctaNet is a budding startup headquartered in Bhubaneswar, specializing in IT solutions across diverse sectors including e-commerce, real estate, automation, and personalized business application. Our primary focus is to provide affordable services to startups, aiding them into their digital initiatives. In addition to our core services, we are expanding into the corporate training sector, aiming to equip future corporate employees with a solid foundation. We also address student needs by identifying academic project requirements, internship opportunities, and offering comprehensive solutions. We are proud to be incorporated as an organization with the Ministry of Corporate Affairs, registered with MSME, and approved by AICTE for internship programs. Also, our commitment to quality is underscored by ISO 9001 2015 certification, ensuring that every project we undertake reaches highest standards of excellence. Okay, thank you so much. That was all. Let us now stage our instructor and start today's session.
Good evening, everyone. My name is Harsh Pranjal, and I will be your instructor for this Python 4-day workshop. Okay. Um, I am a Django developer, and Django is a web framework based on Python only, right? Okay, so let's quickly start with the module. Just give me a second. Okay, just let me know if my screen is visible. Okay. Okay. Mm, okay, now it's visible. So I think there is a lag. Okay, just leave it. So the first thing, the main key question there is that why we are learning Python, right? So one of the very good answer to that is that Python is a very beginner friendly language, easy to understand, easy to go through. That's why we are learning Python. Okay. Okay, quickly just let me know how many of you are beginner in coding languages. How many of you are having Python as your first programming language? Okay. Other than that, uh, the use case of Python in today's development era is very used, right? First of thing that Python is used in data science and machine learning projects like machine learning and data science. Other areas are web development, software development, and many more, right? In current scenarios, there are no such stable Python libraries for app development, right? Android application development, but we will see some Python libraries maybe in future, okay, for app developments. Okay, first of all, what is an interpreter and an IDE? So this particular Python, so okay, so you guys just let me know how many of you are having Python as your first programming language. Or a compiler, okay. Yeah. Or machine level code, right? It will tell the CPU, your computer to what to execute, how to execute this code, all those things. Okay. So to see, yeah. Okay. Okay. So for interpreter, we have many options. Like for example, first of all, we have Google Colab. Okay. It is an online platform. As by name, you can know that it is developed by Google. You can write your Python code in this only, right? One more thing is, see, this one is your Python interpreter. You have to install this particular Python interpreter in your system, right? This is the notebook. So this particular is the Python interpreter. You have to download the Python interpreter for your system and install these all these files for Python interpreter. Okay. Other than that, if you don't want to install Python interpreter on your system, you can use it online interpreter, that is Google Colab. Okay. You can write your Python code here only and it will execute your code, right? See, this is a Python code. A Python interpreter is running in Google Colab, which will convert this code to assembly level or a machine level code, right? And you will get an output. Okay. So let's move forward. Now, what is an IDE? IDE stands for Integrated Development Environment, right? So as you can see that Google Colab is an IDE, right? It can provide you many more functionalities that other than just writing code. You can execute your code. One more feature of Google Colab is that you can directly save your code to your Google Drive, or you can share your code with any other of your friends, right? On real-time basis. Other than that, one of the popular example we have is VS Code. Okay, this is also an IDE. Other than that, many of you are maybe using Jupyter Notebook, Anaconda, or PyCharm, right? Those are examples of Python IDE. Okay, now let's start with Python. Okay, so I'm not going to use Colab because it is an online based and we are not going to develop any particular machine learning model, right? See, Google Colab is very good resource, a very good IDE for machine learning development, right? But here we are going to just go through the basics of Python, right? So VS Code will be enough. See, suppose I have to create a Python file. There are two types of extension. Extension means the particular name written after the dot, right? It will specify to the computer, the system, that what type of file it is. See, if I will provide the extension as .py, my system will recognize it as a Python file. Okay. Now, if I will provide the extension as .ipynb, right, my system will recognize it as a okay. My system will recognize it as a Jupyter notebook. Okay. Jupyter Notebook, the same environment as Python, sorry, as Google Colab, right? You can write your text, you can add code blocks similar to that only, but in your system, not in online environment, in your local system. Okay. So there are two types of file extensions in Python, .py and .ipynb. Ipynb is for Jupyter Notebook. .py is your for your Python code, right? Similar to .c, .c++, .java. Okay. Now we are moving. Yeah, we will be using .ipynb, right? Delete this one. See, okay. So why Python is beginner friendly? See, if you want to print anything on the screen, just use this syntax: print small brackets, inside that pass the particular string. Okay, and it will print That particular string. See, the first time when I am, okay, let's do this. See, the first time when I want to just run my code, my machine will ask me for a Python interpreter, right? So I have installed the particular Python interpreter. My version is 3.10, right? I will choose that, and it will, that Python interpreter will convert this code and print the output. Okay, we will get the output. So inside print statement, always pass any string in double quotes. Okay, right? Okay. Now let's see variables in Python. So what we have, see, to store any type of data. See, suppose you want to perform an operation of 1 plus 2, right? But you want to see the output. For that, you can do something like this: print 1 plus 2, okay? And it will print the output for you, right? One of the other ways that you can create a variable in B, and you will print the output something like this: print A plus B, and it will print the output for you, okay? So these are the variables. A and B are considered as variables. Okay. Now what is a variable? So consider variable as a box, a particular box of memory. Variable is nothing special but a box of memory. Okay. And inside this box of memory, we keep our data 10, 1, 2, 3, whatever you want. A box of memory for a box of memory for B. Okay. We will store 20 years, something like that, 2 years, right? So what is a variable? A variable is a box of memory. Now, there are different types of variable. For this, 1 and 2, these are integers. Okay. We have variables like floating points. 1.2, the decimal number, the real numbers are known as float. Okay, floats. And we have string. Strings are always written inside double quotes or single quotes or triple quotes. Okay, let's see the difference between all these strings. See, if I will pass in single quotes, and if I will print t, okay, so this first three is printed for this a plus b, and this print d, so this d will print the has the particular string inside that variable. Okay, now if I will use double quotes, then again there are no difference, right? But if you will use triple quotes, so triple quotes are generally used to write or pass multi-line strings, right? If I will change the line inside this string, so it will give me an error. Okay, you cannot change line inside a double quote or a single quote string, but inside a triple quote string, you can change lines. And if you will print, you will see the difference. See, it is written in two different lines. Okay, and the single quotes and double quotes are written in single lines because you cannot change the line inside double quotes or single quotes, right? Okay, so yeah, we have a float type. So suppose here we have a variable c, right? Can print the value of c. Okay, we will get 1.2. If you want to see the type of a particular variable, just use print type and pass the variable name. Suppose I want the variable name of c. I want to check which type the variable c is. So it will print float. Okay, variable c is of type float. right? Other than that, we have more types, right? There is one known as Boolean values. Those are true, right? One more Boolean value is false. Okay, just observe this, that the first letter of the Boolean, that is the T of the true, is capital, F of the false is capital, right? It won't accept small t, right? It will give you an error. Okay, so true and false are, as by name it is defined, that it is a true statement, a true condition, a false, right? True and false. Okay. Mm, there's one more variable type, not widely used, but it is there. Let's take my var. So this particular variable is of type complex number, right? Complex number is always written as a plus bj form. Okay. So we have, if I will print my variable, it will print 3 plus 2j, and if I will print the type, my variable, it will print the type as complex. Okay. Okay. So now let's discuss about what is memory in a computer system, right? See, all of you know that there is a RAM in your system, there is an hard disk in your system. Okay. So whenever you write a code, whenever you run a code, that particular code runs in your RAM, and there are some more memories, those are known as registers, right? No need to go deep into these, right? But there are some multiple memories locations known as registers. Okay, they are there to help the CPU to execute your code, right? Suppose this is your CPU, they will help your CPU to execute your code. Okay, what happens that whenever you write a code, that code runs in your RAM, CPU will pick that code. Suppose we have a condition here. Yeah, we have a condition here, that is this a plus b, right? Print a plus b. The value of that a and b are stored in this RAM only. Okay, and the CPU will pick the value of a, the value of b, perform the addition operation, and then return that particular value, the answer, that will be 3 or 5, whatever that is. Okay, so this is how an operation works inside CPU, right? Now, that particular memory is also divided into subgroups. Okay, so there are different subgroups. One is known as stack memory. We have heap memory, right? So there is only, you have to understand only about stack and heap memory. Okay, there are other memories like static and other memories, right? There are total of 5 types of different memories, but you only need to understand about the heap memory and stack memory. Okay, so just listen to these words right now. When we go through this workshop, we will know the use of these types of memory. Okay, yeah. So see how Python particularly creates a variable and how it stores or handle its data, right? We have created that a equal to 1 and b equal to 2. How Python particularly handle this type of data? How Python save 1 and 2 in your system, right? See, what Python will do, it will create a table, right? Okay, we have created two variables, a and a variable b, right? What Python will do, it will create two memory space, a for a and for b. Inside a we have value 1, inside a we have value 1, inside b we have value 2. Now what Python will do, it will connect this a to this particular memory location, it will connect this b to this particular memory location. Okay, this is how a Python memory works. This is how a Python stores its variables, right? It is a very crucial point, guys. It is very, I mean, important to understand how Python stores its variables, right? Because there are certain problems, certain types of events where you have to the answer of those events were inside your how Python stores its data. Okay. Now see, now okay. So this particular memory box, right? This particular memory box have their address known as memory address. Okay. And memory address, see, if I will create, see, consider this as your RAM, this whole as your RAM. Okay. Inside this RAM, inside this RAM, there are multiple small boxes. Okay, this one and two are also created inside your RAM only. Somewhere here one is stored, somewhere here two is stored, right? So each and every memory block that some of you are having 8 GB of RAM or 16 GB of RAM. Every single bit of that RAM is having some particular memory address. Okay, so a particular memory address is always represented in hexadecimal value. See, suppose if I will ask you the memory address of this particular one, it will be something like 0xA16, something like this. Okay, a very big number. See, if you want to see the memory address of this particular, suppose I want the memory address of this C, right? The C written here. This C, I want the memory address of this C. So what I will do, I will print to get the memory address of any variable, use ID. What this ID will do, it will print the memory address of that particular variable. Okay, see, this is the memory address of C. Now in this case, while using ID, it is printed in an integer form 14313, whatever that is, right? But in general, in your memory, these are stored in an hexadecimal format. Okay, for this reading purpose, it is given you as an integer. Okay, now, okay, so see, one yeah, so see how particularly Python saves memory. Okay, suppose I will create a string 1 and I will provide it a value hers. Okay, I will create string 2 and I will provide it a value again hers. See what, according to this logic, what happens that some s1 will be created here, some string 2 will be created here, right? String 2, string 1. Python will create two memory boxes to store the strings. Actually, the size of memory boxes were large. Okay, so what it will do, this will be pointing to this and s2 will be pointing to this. By this logic, if I will try to print the ID, the memory location of string 1, and if I will try to print the memory location of string 2, see, by this logic, string 1 and string 2 are having two different memory locations. So we will get two different values of ID, right? But see what we will get. See, the values of IDs are identical for both string 1 and string 2. The values are identical, right? The memory address is identical. So give me a second. Okay, so this memory address is identical. What do we conclude from here, right? Okay, let me run everything. Yeah, so see, okay, observe one more thing. Whenever you run your code again and again, different memory locations will be assigned to your variables, right? Okay, so from this, what we can conclude that Both S1 and S2 are accessing only one single memory location. Okay, S1 is accessing this memory location and S2 is again accessing this memory location. So this is how Python saves your memory. Why? Because S1 and S2 both are carrying identical values, exactly identical strings. If I will just provide a simple space here, right? See, in this case, we will get two different memory locations. Now string 1 and string 2 are stored in two different boxes. Okay. So if you have identical values, Python will save the memory space and provide only one box to store that value. Okay. Yeah, you can observe the same in sorry, one, one. See, in this case, we again get the identical memory locations. It means both myInt and myInt2 are accessing same box, right? Because both are having same identical values. Okay. But see, assigning the same memory location to store the values is dependent on your compiler, your interpreter, right? Your machine will decide, your Python code, your interpreter will decide whether to assign a single box to store the values or to assign two dedicated box for both strings, right? It is only dependent on your interpreter. Okay, it is not dependent on you or your code, right? So one is here and one is here. Now suppose if both are sharing the same memory location, what happen if I will suppose I will create 100 and if I will assign my int to be added to. Okay, just let me know what happen if I will print the value of mine too. What will the value we will get? Just let me know the output of this line only. Yeah. So the output for this one, what is the value of my int 2? The value of my int 2 is 1. And what we are trying to add 100 to that, the final value we will get 101. Okay. See, what we are trying to do, provide my int 2. Okay. What is the value of my int 2 here? That will be 1, right? And what we are trying to do, add 100 to that. We will get the final answer is 101. And that 101 will be stored to my int 2, right? Then we will get the output as 101, right? So see what just happened right now. See, suppose this both A and B are accessing the same memory location, right? And the value of that memory location is 1. Okay. But now what happened? Both are sharing the same memory location. What happened? I want to perform some operation on A. Suppose I want to perform some operation on this B. I want to add 100, subtract from B, whatever type of operation. So if you are going to perform any operation, what Python will do? It will provide a dedicated memory for that particular variable, provide the value inside that, and it will delete this particular connection and a new pointer will be created. This copy will be created there. In this case, now if I will print the ID of my int 1 and my int 2, in this case we will get two different memory locations. See, the memory location are two different memory location. Okay, now just let me know What will be the output of this print statement if I will run this code again? What will be the output of this print statement if I will run this code again? See, it will be increased to 300 once more and it will be increased to 400, right? Why? Because my int is also incrementing. Right now, what is the value of my int 2? It will be 401. And inside that 401, we will try to add one more 100. We will get 501. Okay. Now, so this one is a typical part, the how memory is assigned and how Python works with memory. Now let's see some basic operations on variables, right? So we have what we have. Let's say some arithmetic operation. Suppose we have A as 100 and B as 200. If we will print A plus B, we will get the value as 300, right? Simple addition. Similarly, simple subtraction. This particular one, multiplication, division. See, this modulo operator, right? It is also known as ampersand. Okay, so this modulo operator is used to get the remainder, right? So if you try to divide 100 by 2, okay, in this case we won't get some good remainder. Let me take a good example. Just let me 299. If you will divide 100 by 99, what we will get? Remainder as 1. Okay. See, this A divided by B, it will give you the answer when you will divide that particular two numbers. If you will divide 100 by 99, you will get this answer, right? It is again, it is a floating point number, and the decimal, I think this decimal will contain a very long number, right? Unnecessary digits are there. So we will see how to remove these unnecessary digits. Other than that, we have seen this particular multiplication, subtraction, addition. One more thing is there, one more operation, that will be A. If you will apply double asterisk B, what it means that it is known as E raised to power B, right? 100 to the power 99, and it will be a very long digit or number, right? Printed in a very long manner. Let's take a reasonable number. Yeah, so 100 square is 10,000 only, and it is written here, right? So double asterisk is used to print the power A raised to B. Okay. What happen if I will see, suppose you have a question in hand, that is you have to find the cube root of a number, right? I have a number that will be 300 and I want to find the cube root of that number. So what we will do, cube root means 300 raised to the power 1 by 3 only. That is cube root. Okay. So we have print 300 asterisk 1 by 3. So what this will do, this will print the cube root of 300, right? Okay. So if we have a good number like 9, and instead of 300, let's use num, we will get the cube root, and for 27, we will get the answer as 3. Okay. Okay. See, this is not 3, this is 3.0, right? So keep in mind, whenever this particular answer will be returned, it will be in float value. It is a float value, not int, not integer. It is a float. Okay. Okay. So these are some basic mathematical operations. Now let's see. Okay, so you guys must have heard about the OR operation and AND operation, right? So see, for OR operation, if you will perform true or false, what we will get? We will always get true, right? So this particular single line, this is used to perform OR operation. Okay, print true and false. This single AND is known as is used to perform AND operation. Okay, there is one more operation that is known as XOR operation, right? We have true, XOR, false. So it will print the XOR operation. The output of XOR operation will be true. Okay. Okay. So just let me know what will be the output of this particular operation. True, XOR, true. What will be the output of this print statement? Okay. Let me make some changes here. Let's take true as true and yes. What will be the output of this particular print statement? Okay, so true XOR true will provide you a false value, right? That is the property of XOR operator. Okay, so we have seen. Okay, so these operations are known as bitwise operation. Okay, these particular operations are known as mathematical operations, right? Okay, so we have seen different types of variables. Okay, so if you have already gone through any particular programming language, then you know there is a data structure, a particular variable known as array, right? In Python, what we will do, suppose if I give you a task to numbers, to store a total of, suppose if I give you a task to store 300 numbers, right? So in this case, what you will need, some variables a, b, c, d, something like this. You need a variable up to 300 different variables, right? Instead of that, what we will do, what we will do, we will create a single variable, suppose L, and what we will do, we will create a bunch of memory, okay, divided in different boxes, right? Multiple boxes like this, okay? And what we will do, we will assign this L to this particular memory. Now what happened? We will store one number here, something like this. You can store multiple numbers inside a single box, inside a single big box, right? See how that is done. This particular memory is only known as array. In case of Python, it is known as list. Okay. See, if I will create a list, this is the syntax to create a list. Square brackets. Inside square brackets, you will provide comma separated values, the values you want inside your list. If you will print my list variable, see, you will get the particular values. Okay. Yeah. So see, if you want to access a particular value from a list, you can access like this. See, there is something known as indexing. Okay, what happened inside indexing? These particular memory locations, these memory locations will get a value starting from 0, a counting value, 0, 1, 2, 3, and so on. Okay, those are known as indexing. This particular one will get the index of 0, this 2 will get 1, 3 will get 2, and 4 will get 3, right? If I will print my list 0, we will get only the value stored at 0th index. Always remember the indexing will start from 0, okay? And if you want to access only a single variable, a single value, just use square brackets inside that provide the index, okay? By this, you will access only a single value from your list, your array, okay? What is list? List is nothing but a continuous memory, a very big chunk of memory divided into small boxes. And inside each box, you can store values like 1, 2, 3, 4, or something like uh, 600 and 700, right? If I will try to print my list 10. So what I am trying to do, I'm trying to print the value at index number 10. In this case, I will get an error, right? This error, just remember the name of the error. It is known as index error, right? What happened? See, inside this list, provide the indexing. Is there any index exist with index number 10? No, right? The maximum index we can go up to is 5. That's why we are getting an error here. Why? Because this index number 10 doesn't exist inside your list. That's why we are getting error. If I will print my list 5, I will get the value. That will be 700, right? If I will print my list 6, I will get an error because this index 6 doesn't exist. There is no index 6 in my list. Okay, yeah. Same functions will work here. If you want to check the ID, the memory location of your variable, pass my list. If you want to check the type of your variable, pass your variable name. This one is the ID, and see it is the variable type is list. Okay, okay. So now, before jumping to the different functions or methods inside list, different properties of list, let's discuss some one of the very important, or you can say the key value of Python, the key differentiator of Python. See, Python is a dynamically typed language. By dynamically typed, what I mean that, okay, let me give you an example. See, I have a variable a and I am providing an integer to that variable a, right? So right now at line number 1, a variable is storing 1. Okay, if I will print type of a, it will print string, right? See, this type of a is, sorry, the type of a is nothing but class int. Okay, just, yeah. Now see, in line number 5, what I am doing, I am assigning a string to that particular variable. Okay, now in this case, right now, what happened? See, the type is string. What happened? At first, a is containing 1, but right now a is containing a string. That same variable at a point of time, at an instance, is storing an integer, but at an instance it is storing a string, right? It is not allowed in other programming languages like C++ or Java or C, right? It is allowed in Python and it is also allowed in JavaScript. Okay, so this is known as dynamically typed language. In your runtime, in your particular code, you can decide what type of value will be stored by your variable, right? So how Python achieve this, right? See, we have seen that Python creates a table. Suppose at first Python creates the table, assign A here, assign a small memory location, and yeah, this is how Python store that particular integer value 1. Now, if you want to store a particular string inside Python, what it will do? It will delete the previous link. It will create a new link to this new memory location, and this previous memory will be deleted. This is how Python achieve to provide different types of variables, different types of values to the same variable, right? Inside this, you can provide your string, right? See, after the string, if I will do a is equal to 3.4, in this case, if I will print, in this case, the type of a is nothing but float. Okay, so you get the meaning of dynamically typed. It means the type of your variable, the type of data your variable is storing always change. It can change according to you, right? Okay, so yeah, now come back to C. We have seen that uh, it is a dynamically typed, right? One more thing, we are creating a very big chunk of memory to store data in list, right? So what happen if I will store integer in all these boxes and I want to store a string in this particular box? I want to store a float in this particular box. I want to store a particular whatever um, boolean in this particular box. You see, we will create my list, right? What we will do, want to after that we want a string. After this we want a boolean value. After this we want a float, right? Into my list. See, see, right now I don't know the size of this list. I have to count from starting, right? 1, 2, 3, 4, 5, 5. The size of this list is 5. But there is one function you can use to print the size of your list. That function is known as length. Len function, okay? Len, right? This will be used to print the length of the string. Suppose I will create a variable n and I want to store the length of this list, and I will print n. See, what is this? This is nothing but the length of my string, my list. Okay, observe one more thing, guys, that as we start our indexing from 0, 1, 2, 3, and 4, always the last index is always of the value n minus 1, right? N is the length minus 1 value. Okay, see, the length is 5, so the last index is 4. If the length will be 6, okay, so the length will be 6, then the particular last value will be 5, right? Okay, guys, just let me know if any one of you having any doubts till now. Okay, so let me quickly summarize it. Uh, yeah, guys, so I got a doubt, right? Is Python is case sensitive? So by case sensitive, it means that if I will write the print in capital P, see, it throws an error. It will give me an error, right? So yes, Python is case sensitive. You have to write this in small letters, right? In lowercase, because this particular print, this particular keyword is in lowercase, right? Yeah. Yeah. One more thing, all these things, right? This print, right? This type, and we have one more. We have seen one more ID, right? We have seen one more, that is length. That is, yeah, this length. These are reserved keyword in Python. Okay, reserved keyword by mean that these have special meaning in Python, right? You cannot create a particular variable with the name len. After this, if I will see, if I will do, I will try to print the length of my list. What happened? I will get an error. See, I will get an error. Int object is not callable. So never try to create a variable of a reserved keyword name, right? Okay. If you have any doubt, then put that on the chat. Yeah. See guys, once I have created that keyword with length, right now I am getting error everywhere, right? I have deleted that line, that particular line where I have created the variable name length and assigned some integer value to that. But again, I am getting some error, right? To fix this type of error, you have to restart. Okay. That's why never try to create a variable of the name keyword, right? Okay. That's good. Yeah, we have reserved keywords. Now, so now let's move on with list. Okay. So we have my list. Suppose I have values. Okay, so we are talking about how a particular list stores value, right? See how, just try to understand this particular memory logic, right? This will help you to better understand the upcoming topics. Okay. See, uh, we have a table. Okay. We have a very big box divided into small boxes and so on, right? Inside this table, we have the name of our variable, that will be list, and list is pointing to this array, right? Now, if this will be a simple array in other languages, okay, so in other languages, an array can store only same data type. By same data type, I mean that if it will be an array in other language, then you can only store an integer data type inside this particular array, right? You cannot store a string, boolean value or float value inside an integer array. But in Python, you can store any type of variable inside list. Why? Because Python is dynamically typed, right? So how list achieve this? How list achieve this particular functionality to store any types of variable inside it, right? So what happens? See, suppose I want to assign a particular, integer here, right? Suppose that value of integer is 1. So how Python will create this one? It will create a memory somewhere in your RAM with value 1, and as it is a chunk of memory, a box of memory, this memory should have some address, suppose 0x, right? Now what Python will do, it will store this 0x here, right? This 0x will be stored here. Whenever you will try to access this particular box, right, you will get this 1. The memory 0x will be stored here. See, if I will try to print my list 0, what happen? I will get 1. How come I will get 1? So at 0th index, we have a memory address and Python will print the value of this memory address. Value of that memory address. Value of that memory address is 1. If I want to store a string, suppose I want to store a string, right? What Python will do? It will create some memory location somewhere. It will assign a string here. Okay. Suppose the memory location of this box is 1x. It will store this 1x here. Okay. Right. So that's how Python handles memory or create a list. So so this is your actual list, right? This is your actual list, and your actual list carries the memory address of different variables. There may be somewhere 2x, there may be somewhere 3x or something like that, 7x, nx, something like that. Some variables are stored there. Okay. So what your list will carry? Your list will store memory address of the values. Memory address of the values. If you are taking notes, then please highlight this word. Your list will carry memory address of values. Okay. So first thing, yeah. Now, so we have that is like 4.5, that is like 7, that is like true. Now see, inside this list, I want to create another list, right? Inside this list, I want to store 200, 300, hello world, right? How this is achieved? Again, at some point, at some location, a new list will be created, right? Suppose this particular memory chunk is having some memory location, suppose 2x. That particular 2x is stored here. For this memory location, different types of memory locations are created with values, right? First one is holding 200, second one is holding 300, third one is holding some boolean values or string, whatever that is. So this is how a nested list will be created. This is known as nested list. Okay, a list inside another list. This is how it is achieved, right? Okay, now see, let me take the length of my list. Okay, and let's print the value of n. So it is 6, right? The length is 6. See, I will print my list n minus 1. This n minus 1 is nothing but this last particular index, right? See, we have an index of 0, we have an index of 1, 2, 3, 4, and this whole list will get an index of 5, right? So the length of your list is 6. The last wind index, the index of this particular last object, last value will be n minus 1. If I will print this, see, I will get the whole list eh, stored inside that particular index, right? See, if I will do print a particular index, what happened? See, this first will be resolved. This first will provide you the particular whole list. After that, what we will pick? We will only pick the zeroth index, the zeroth value. And the zeroth value is nothing but 200. Okay. Okay. Now, if I will do, see, this particular string, or we have seen strings here, right? So strings are also subscriptable. Subscriptable means strings also supports indexing. If I want to access the, see, if I want to access only this R, right? So this R is at index 0, 1, 2. Okay. See, we will get only the value R, right? So what happens? Suppose I want to access the R of this particular string, R of this particular string. So how I will do that? First of all, what is the index of that string? That is 1. Now, what is the index of R? That will be 2. In this case, see, I will get an R. So try to figure out what will be the output of this. What will be the output of this line? Just let me know the output. Yeah. So the output will be E, right? See, what this will pick? This will pick this whole list, the last element. What this 2 will pick, this particular 2, it will pick the particular string, because this string is at index 2, right? 0, 1, 2. This string at index 2. Now after that, what this 1 will pick, this will pick in the element at index 1 of the particular string. That will be E. Okay. So this is how a particular list will work, nested list. Now let's discuss about functions in list, right? Okay, there are multiple types of list methods. The important ones are append, clear, we have reverse, we have sort, what else? Copy and pop. Copy, and we have pop. Okay, so these are list methods. Now, what are these list methods? Suppose I have a list, right? Let's create a list with, yeah, 10. See, there are multiple ways to create a list. This will also create an empty list, a blank list, right? This will also create a blank list. Okay. So right now, if I will try to print temp, what we will get? We will get nothing. Why? Because it is an empty list, right? Let me comment out this one. So this is an empty list. Temp is an empty list. Now let's see append. So what is the syntax of this append? List variable, list variable dot append, and inside that we will pass a value. See how this works. Temp dot append 5. Okay, and now I will try to print temp. See what we will get. We will get 5. So append is used to insert elements inside your list. Now observe one more thing. See, append will always insert the element at the last of your list. Okay. So what append will do, it will insert elements at the end of list, right? Okay, after append we have clear. See, if you again want to, okay, let's see clear at the very last. Okay, so we have, let's get some more values inside our temp, right? Let's try append some more time. See, you cannot pass values like this, the comma operator, right? Suppose you want to provide some more than one values, you will get an error. You can pass only one value at a time. Okay. See, if I will try to append a particular list, right? I try to append a particular list. Uh, Suppose that list will contain us and a value 200. Let me print this 10. What append will do? Okay, so note this one. Append will insert the particular elements at the end of the list. So this whole list will be treated as a single element, and that particular element is inserted inside your list, right? Okay. Now we have we have pop. The syntax of pop will be your list variable dot pop, right? There is one more syntax for pop, that will be list variable dot pop index value. See what I mean. If I will, okay, if I will perform temp dot pop, it will delete, pop will delete the last element, okay, the last element of your list. See, this particular whole list was our last element. The pop will delete the last element of your list. Okay, delete last element of list. Okay, now if I will pass a particular index, sorry, we have temp dot pop. If I will pass a particular index, what is the index of this 50? So the index of this 50 is 1, right? If I will pass a index, what happen? It will delete that particular index, delete the value of that particular index. So there are two, you can see there are two functionalities of pop, right? If you provide an index, it will delete the particular index, the value at that index. If you don't provide an index, it will delete the last element, right? Okay, now we have seen pop reverse. Yeah. So no need to explain about reverse by name. You can know that it will reverse your list. Now, if I will print temp, what happened? So it, see, our list is reversed. Okay, okay. It is hard to understand with only two examples, right? Two values. Let me insert some. Okay, let me provide you a new concept. See, suppose I have a list one, okay, and I have a list two, right? And I am just trying to add both of them. This is the simple mathematical operation, that is add 1 plus 2 is equal to 3, something like that. What happened with this add operation? We will get a bigger list, a very bigger list, and this list contains each and every element from both the list. right? Each element of both the list. Okay. This particular operation is termed as concatenation. Concatenation means merging of two lists into one single one, right? See, this is how we perform concatenation in list. We have a list temp. So what I will do, okay, just this one. See, I have a list temp. I want to concatenate these values. I have 10, 8, then I have 4, then I have 2, then I have 1, then 3, right? So you can provide any values, string values or whatever values inside your list. We have seen that. Now, what do you want after concatenation? Where do you want to store your this new list, this bigger list? So I want to store that list inside my temp variable only. I don't want to create any other variable. I just want to modify my temp variable only, right? See, now if I will print temp, what we will get? We will get a concatenated value, a merged value of both the lists. See, observe the difference between append and concatenation, right? Append has inserted that particular list as an element inside your list, but in list concatenation, it is merged, right? There's a difference between merging and inserting as an element, right? Okay. Now see, now let me perform this reverse after this. So after this reverse, see each and every value are reversed. Okay. We have one more thing. Reverse we have seen append, reverse, pop. Okay. Let me show you sort. Okay. So by name, you can know that sort will be used to sort the particular list in ascending order, right? See, your list will be sorted in ascending order, right? If you reverse this particular temp right now, you will get your list sorted in descending order. See, your list is sorted in descending order. Okay. But there is one more thing. Instead of doing this, there is one more requirement. I mean, there are another methods to achieve a sorted list in descending order. That will be reverse equal to true. What this will do? This will sort your list in descending order. Okay. And the previous one, temp dot sort in temp. This will sort your list in ascending order, right? So just remember these syntax. Okay, these syntax are very important one, right? Remember these values, the keywords. Okay, yeah. Suppose I have a string inside my list, right? I will print temp right now. We have a we have a string at the end. So now I will try to sort my list. See, in this case, we will get an error. And why this error? See, when we have all the elements of same data type, it is easy to use greater than or less than operator, right? How you can sort an element, how you can sort a list. You can compare one element with other. A is greater than B, 10 is greater than 2, 3 is greater than 5, something like that. But how you can compare this particular string with any values? Can you compare 60 is greater than hello, or 5 is greater than hello, or hello is greater than 8? No, right? So that's why we are getting an error here. So whenever you are using sort, always take care that the values inside your list are of same data type, right? Okay, instead of this, let's provide a single. See, I have a 5.6 here, a float. Float is okay. You can compare 5.6 is greater than 5 or 5.6 is greater than 8 or less than 8, right? You can compare that. But with a string, there is a problem, right? So whenever using sort, always take care of the values stored inside your list, right? You can compare a boolean value and a integer value. There is no problem with that, right? But not a string and a integer. Okay, so we have seen the crucial points of sort also. We have seen pop, reverse, append. Okay, take care of this also. This is also important. The reverse equal to true one. Now we have clear. By name, it is clear that it will delete all the elements, right? It is nothing but your list var dot clear. See, if I will do temp dot clear, what happened? It will delete each and every element from temp. See, now my temp variable is empty. Okay. Okay, guys, just let me know if you are having any problem till now. Any doubts about any keyword or anything, memory allocation or something like that? Okay, so we have almost covered all the methods. There is one, this copy one is remaining, right? And there are many more methods, right? This insert and sorry, this insert, we have this insert and index, right? So figure out those things by yourself, try to practice those keywords, will get to know. Okay, these are the important ones, and these functions, these methods you can use now and then. These are, now let's go with this copy. Okay, so see, what is the problem with, see, we have seen that how Python allocates memory, right? So what is the problem with that particular allocation? We have a variable. Okay, let me first create the list. We have a variable L here, right? These are the particular boxes where we have stored the values, the location of those values. Suppose I have another variable list 2, and this list 2 is also pointing to this location, right? In this case, see, we have seen the earlier case where Python do these things to save memory, right? In those cases, see, we have seen this case where Python use, yeah, see, in these cases, Python use the same technique to save memory, right? Okay. But see, whenever we are performing any operation, Python will allot different memories to both the variables, right? But in case of list, Python doesn't control this. If you want any change in list 2, this change will be made in the same list only. If you want to delete this element will be deleted. That change will be reflected in L or L2 both. See what I mean? I have a list L1 with values. Okay, I have a L2 equal to L1. This is how we assign a value, right? A is equal to 1, B is equal to A, something like that. Okay. See, if I will do L1 dot pop, I want to pop a particular index, suppose only pop, right? This pop will delete this hello. Okay. Now, okay, let me first do a print L2, and after this pop, print L2 and print L. See, sorry, this is L1. Yeah. See. that hello will be deleted by in the both list. See, we didn't perform pop on L2, right? But the value hello value is deleted from both the list L1 and L2, right? See, if I will print the ID of L1 and I will print the ID of L2, we will get the same identical memory locations. So when you are performing any operation on L1, either L1 or L2, Python doesn't handle that particular memory copying and creating two different boxes for different variables, right? We have seen that in string or in integer, right? Whenever you perform any addition or subtraction, Python will create two different boxes for my int1 and my int2. But in this case, Python doesn't do that. So what I have done, I have just deleted this value, and both list L1 and L2 are accessing the same list. So that's why this particular value is on deleted in both the lists, right? So how to handle these? To handle these types of scenario, what we will do, just first let me just, yeah. So this line is the problem, right? L2 equal to L1. We have to do L2 equal to L1 dot copy. Now see, if I will print the ID of both L1 and L2, at first the ID of both L1 and L2 are different, right? It means we told the Python interpreter that we want different separated memory locations for both lists. We don't want to optimize memory and create a single list. We want the memory for two different lists, right? Now see, we are performing pop on L1. So only the value of L1 is deleted. Okay, it is printed in reverse order. Yeah, the value of L1 is deleted and the values of L2 are intact there. Why? Because right now there is a new list, a new list is there, okay, and instead of pointing to the same memory location, L2 is pointing to this new list. So if I will delete this particular element, it is not going to affect my this L2 list, right? Because we have done all the copy process, all the values are present here, right? Okay, so this is how we use dot copy. Now guys, there is one more exception, or you can say there is some problem also. Suppose if you have L1 and all the values of L1, right? So inside this L1, suppose there is some nested list, right? And I do L2 is equal to L1 dot copy. Okay. Now if I have, let me just print L1, print L2. Suppose I want to perform, what is the index of this one? Let me take length of L1 n minus 1. Let's pick the index 0. Okay, just let me know the output of this print statement only. What will be the output of this print statement? What will be the output of this print statement? Okay, so the output of that print statement is what we are trying to do. We are trying to access the n minus 1 index. Okay, what is n? The length of list 1. What is n minus 1? This particular index, right? We want to access this particular index. After that index, we want to access the 0th element of that index. That will be this 100, right? So this print statement will print 100, right? See, we get 100. Okay, but now what happened? Okay. What we are trying to do, we are trying to add 200 to this particular value of 100, right? We are trying to add 200. In which list? In our list 1. Okay, so let's see, is that change will be reflected in both the list 1 and list 2 or only in the list 1? See, whenever we are dealing with a nested list, again the changes were reflected in both lists, list 1 and list 2. What happened? In this scenario, I am changing this one particular value. That same value will be changed inside my list 2 also. So there is no, no benefit of using this copy. So when to use copy? Whenever there is a simple list. Okay, whenever there is a nested list, always use deep copy, right? Okay, so the syntax to use deep copy will be list 2 is equal to copy dot, we have to import it first. This is the particular syntax, right? Now see, after this one, see, the value is only reflected in L1, not in L2, right? So whenever there is a nested list, always use deep copy. If there are no nested list or anything like that, use copy. Copy will be enough, right? Now see guys, what is this particular statement, import copy? What is this? See, suppose I have, see, I have a particular variable in this test.py file, right? And the name of that variable is myvar. Okay, I want to use that particular variable in my code right now. In that case, what we will do, we will type from test import myvar, and we will try to print the value of myvar here. See, we will get file 1, but that particular variable, that particular value is written in some another file, right? But we are accessing that variable, we are accessing that value here right now. Okay, so how this is done? This particular from test, this test is defining the file name, and this, after this import keyword, the what we want to import, we want to import a variable, a function, a class, whatever that is, we write the name of that. Okay, so let me give you the correct syntax here, and instead of writing this, let's write a copy. See, what is this copy? This copy is some file known as copy.py, right? What you will do, just press control, hover over it and click, right? It will open the file copy.py for you. Inside this copy.py, we are looking for deep copy. See, deep copy is here, right? Deep copy is defined, how deep copy will work and what is the function of deep copy. Everything is defined inside some another file. We cannot define that here, right? It will unnecessarily increase the size of your code or number of lines, right? So that's why we use functions or variables from some other file. So this is the syntax to use, right? This particular file, this copy.py, or in case of this test.py, these are known as libraries or modules, you can say, right? Inside these modules, different types of functions or variables are declared, something like this var, myvar, right? These types of variables are declared there, which we want to use in our code. See, we want to use deep copy. Instead of writing hundreds of lines of code to implement this deep copy, we are just using that particular deep copy function, right? Deep copy variable method here, right? See, instead of specific, see, I have specified here that I want to import only my var. Okay, suppose I have some other variable here. Okay, so see, in this case, I will get an error. Why? Because I am not importing my var2. Okay, so just write the name of the components, the elements you want to import from other files. If you want to import my var2, just give a comma, write my var2. In this case, now it will run. Cannot import name. Okay, so I think it is in some 3.5. Let me provide a string. It's okay, good to go. Yeah, we are again getting an error. Okay, let's discuss about this error also. See, guys, in that case, we are getting an error. So there is one more way to import things, right? Just write import test and let me write print test dot my var2. Okay, give me a second. Just see, to import any particular modules, to make that module to work inside any other file. See that this copy.py is written somewhere else, right? We are using only a particular functionality of that copy. So there are certain criteria, certain rules to write a module, right? See, if you have noticed that when I use this test, a new folder will be created here, right? By catch. Let me delete this one. Let me put my var2. Let's see if it will be imported or not. No. So guys, to import multiple things from a particular file, there is one file, one particular file that is known as init.py. You have to create this file. You have to write rules inside this particular Python file, right? You have to create rules that whenever someone is using your importing elements from your test.py file, that how those elements will be imported, what are the use of those elements, how those elements will allocate memory. Those rules will be written inside this init.py. Okay, just leave these things. We will again visit these topics. Right now, just understand that we can use different types of variables written in different files in Python by using these types of statements. Okay, yeah. So we have covered lists, right? Now let's see. There are uh, many more things ever related to list. Example, let me just take a list here. Okay, we have a topic. This is known as list slicing. See, suppose I have okay. See, suppose there is a scenario I want to only print these three values, right? Only these three values. Okay, so just let me write the index so it will be easy. Okay, before slicing, Python also supports reverse indexing. By indexing, I mean that there are indexing provided in negative also, right? -1, -2, -3, not -3 will be, -3 will be in this 8, right? Okay. See, if I will print list variable -1, it will print the last element of the list, C60. If I will try to print 7, this again prints the last variable. If I want to print -7, in this case, I will get an 2, right? See, 2 will be at -7, -3, -4, -6, whatever that is, -7, right? So Python also supports negative indexing, right? Now suppose there is a scenario where I only want the elements from index 1 to index 3, only this much elements, right? So what we can do, we have one option to do list var index 1, index 2, and we have index 3. This is how we can get 3 index. Suppose we have a very large list of 700 elements and we want to pick the middle 4 or 6 400 elements, right? So how to do that? So we have one more thing known as list slicing. In this, what we will do, your list variable name, square brackets, right? Inside this square brackets, we use to provide index, right? A particular index to print the value. If I will provide -4, it will print the value at -4, that will be 5. But see, this is how we provide slicing. A colon, right? The first index will be the index from where you want to start your printing, the index 1. The last index will be the value, the index you want to print plus 1, right? I want to print the index number 3. The last index will be index number 3. So I have to provide here 4, right? In this case, see what we will get. We will get all the elements from index 1 to index 3, right? This is the syntax of slicing. List var start index plus end index, and how it will iterate, what it will provide. So it will provide you elements from start to end -1. Always keep this in mind. It will give us end -1, right? Now see, if inside these columns I don't provide any value, what we will get? The whole list, the whole list. So by default it means if you are not providing any value, the start is 0 and end will be n. N means the length of the list, right? So the length of the list is 7. If I will provide 7 here, see what we will get. We will get one less element, right? So we have to print elements till 7. So what we have to provide here? We have to provide here 8. And 8 is nothing but the length of your string, sorry, list. Okay. So end is always the length of list. These are the default values if you don't provide any value. Okay. Now suppose I want to get the values from 0 to 3, right? So what I will provide 4, and I don't want to provide the starting value, right? Because starting value is by default 0. I will get from 0 to 4, 0 to index 4, sorry, 0 to index 3, right? 0, 1 to 3. Okay. Yeah. Now, see, there is one more thing. Um, there is one more column, and after this column, see, I have passed 2, right? I have written 2. What happened? See, if you can observe, this is our list, and in this case, every alternate element of the list is printed here. 1, then 3, then 5, then 10, and there is nothing after 60, so 10 is the last element we get. So what is this? After the second column, jump is given, jump, the particular jump value. By default, it is 1. See, in this case, there is no jump value. In this case, there is no jump value. So by default, the jump value is 1. In this case, it is only jumping by 1 from 1 to 2, 2 to 3, 3 to 4. But in this case, in our last print statement, I have provided a jump value of 2. So right now, from 1, it will jump by 2, 1 and 2. The second element by jump 2, we got 3. After 3, it will jump by 2, we got 5. After 5, it will jump by 2, we got 10. After 10, it will jump by 2, and there is nothing, so we get the last element as 10, and this is our final list. Right, guys? Okay. Now, these are the do's. What are the don'ts? Means the error-prone areas in list slicing. Right. So, print list var 4, 3. See, what I want to print only these two elements. But see what I have passed here. I have passed 4 and 3, and I am not providing any jump. So the default value of jump is 1. Now, just let me know. Suppose I am standing in this 5 and I want to reach this 2. But what is allowed? It is allowed that I can jump by 1 in positive direction, right? From 5 I can go to 8, I can go to 10, I can go to 60. But from 5 I cannot go to 2, right? In this case, I will get an empty list. Why? From starting from 4, I am starting at index 4. I cannot visit index 3, right? But if I will provide, but I will provide if the jump as -1, it means we are now jumping in negative direction in reverse order. In this case, see, we got 5. Why? Right now we are standing at index 4. I will jump by 1, that will be index 3. But we know that it always print up to end -1. It means the end index, this particular end index is neglected. So we got our first element, that will be 5. I will provide 1, we get 543, right? So you can provide negative jumping, you can provide positive jumping, right? Now, see, in this particular case, we got our there is no 8th index, there is 6th index. So in this case, we got empty list, right? This empty list because it is not possible. But suppose I'm standing at 3, right? And I want to print this 4, 5, 8, means this index 3, 4, and 5. So this is the correct list slicing for that. But if I will provide a negative jump to this, means from 3, I'm allowed to jump in the negative direction. See what we will get in this, again in this case, we will get an empty list because it is never possible to start jumping from 3 and to reach -1, sorry, to reach 6 by jumping in negative direction, right? So this is all about list comprehension. As there are, you can say that where we have, yeah, here only. As you can see that there are negative indexing, so in list also there are, you can, in list comprehension also you can use negative indexing. We have, suppose, print list where I want to print from -1 till -4. We have -1 here, -2, -3. So I want to print this 60, 10, and 8, right? See, in this case, again we will get a empty list, right? Why? So you have to define it like this: -4, -1, right? We got the element 5, 8, and 10. We have to get 8 to 60, right? So from -3, I want from -3 to end all elements from -3. So see, in this case, we are getting 8, 10, and 60, right? So why this, guys? Because the jump value in this, again, the jump value is default, that is 1, so positive 1. So you cannot reach from -1 to -4. Our first example, -1 to -4, we cannot move from -1 to -4 by following positive jumping, right? Positive 1. Okay, we cannot do that. But what happen if I will provide a negative jump value? This is our jump value -1. See, now in this case, we will get our output, because in this case, it is possible to reach from -1 to -4. It is possible to reach. Why? Because we have a negative jumping there, right? So you can play with list slicing as you wish. There are many more combinations there, but there is one benefit of using list slicing. Yeah. Suppose you want to create your list var 2, right? And you don't want to use copy, deep copy, or anything like that. Just use list slicing. List slicing by default use copy, right? I mean functionalities like copy. It will create a different variable. So let's use, we just keep only these. Print ID of list var, list var 2. See, in this case, we are getting two different IDs. It means list 1 and list 2 are at two different locations. And if you will print list var 2, we have all the values of list var 2. Let me just perform a quick pop operation in list var 1, and let me print the list var 2. See, the values of list var 2 are not affected, right? So you can use slicing for that also. See, I have not provided any jump value or anything or any value, so each and every value are taken as default in this case, right? If I will provide a jump value of 2, so all we got all the alternate elements starting from start to end, right? So this is it about list slicing. We have seen the length function, right? We have seen the concatenation. Yeah, guys, just keep this one in mind that whenever you are using copy or sort or reverse functions like this, you have to, these are the syntax, right? These are the syntax for each and every methods. List variable dot that function name, list variable dot that function name. But in case of length, where we have used, in case of length, this is the particular syntax. Okay, length bracket, then your list variable name. So, so just take care of the particular syntax. Okay. Okay, let me know if you guys are having any doubts till now, any topic, memory location, or how Pythons handle memory list or anything. Any doubts till now? Okay, notice. So let's move forward. Hmm. What we have next? Dictionary functions recursion. Okay. See. So we have seen different types of values, right? Variables. Suppose what happen if you want to start assign or create a variable of type integer but without any value. We have seen that you can create a list without any value, right? An empty list. How to create an empty integer? In that case, use int. This is the syntax to create empty integer. This is the syntax to create empty string, right? If you can print the type of b, that will be an integer, right? But if you will print the value of b, there is nothing else, only 0. Now guys, see, we are getting 0, but we didn't assign anything here, right? We are getting 0. 0 is also a value. So how come that? See, whenever Python creates a particular value, okay, so this tuple and sets. Okay, we will see this particular questions in tomorrow's session, right? For that, I have to explain the tuple and set also. Okay, so tomorrow we are going to cover tuple, sets, and dictionaries. See, whenever Python creates a particular memory, right? Inside that memory, there are some garbage values, right? So what Python will do, it will assign a particular value for that memory. If you are not assigning, see, I didn't assign any value for b, but we are getting 0, right? So this is the work of Python. Python will assign a empty value, a value 0, to this particular memory location if it is an integer. If it was a string, what I will get, see, for string, I will get nothing. See, one line is printed here, but you can't see it. Not even, it is not even a space. It is just a blank line, nothing else, right? And for list, we have seen that we get two square brackets. See, there is a line here printed here. Okay. Other than that, see guys, let's just discuss about some of the good practices to work with Python to write Python codes. Okay. One of is that, see, always describe the data type you are going to store in that particular variable. See, this is the syntax to how to tell. See, it is not always going to happen that you have written a code and you are working on that project, or you are only working on that code. This will help other peoples to notice that, or to know that what type of variable this a is holding, right? So this time I have defined it as int. It will help others to know that what type of variable are stored inside a. So this int doesn't bound a to store only int data type. You can store anything. Okay, there is no problem with that. It doesn't throw you any error. Okay, but it is just a good practice. You can also provide any float value here. It won't give you any error, right? Just a second. So you won't get any error for this also. Okay, guys. So always keep in mind the type of a variable in Python is always determined by what type of value that variable is holding, right? So right now it is holding 10.4, so that's why we are getting float. Okay, yeah. Okay, so consider it as your practice work, right? Try to implement all these list methods by yourself, right? There are more methods listed here. There are more methods here, right? On this one, insert, and we have also remove. Okay, and there are also other methods. So just try to figure out the use of these methods. Okay, and these are the important ones. That's it for today's session, guys. If you are having any doubt, then let me know. Otherwise, we will end the session. Yeah, that list, tuple, and set differentiation, we will see about that tomorrow, right? Okay, guys, so let's end the session.